Hi there, my name is Goelen. I'm a PhD student at the University of Birmingham, and my work is aiming to quantify fluid volumes and their distribution in the pediatric colon via magnetic resonance imaging. Because of the potential of protein absorption in the colon has gained increased interest for pediatric drug delivery. However, the amount of fluid and fluid distribution in the colon is critical for drug dissolution. If we know these fluid parameters, modeling software can more accurately predict the behavior of these colon-targeted drug delivery systems in vivo. MRI has been employed before to look for the amount and distribution of fluid pockets in the colon in adults. Here, the average values range from 2 to 13 milliliters of colon fluid in fasted state, but the individual values vary widely between patients. My research aims to use MRI as a tool to quantify these fluid parameters in the pediatric colon based on a similar research previously done in our group for the pediatric small intestine. We received 48 anonymized datasets of 2 hospitals in Birmingham and Coventry. Patients were required to fast overnight, and in addition, patients from Coventry were also asked to drink half a liter of a microgol solution 1 hour prior to MRI acquisition. Both groups had a roughly even gender split. Then we used 2 software packages to analyze the datasets. Firstly, we used HOROS, secondly, MSJ. We used HOROS to color the free fluid in the datasets. For this, we selected MRI slides that most clearly showed the cerebrospinal fluid in the spinal canal, of which we calculated the average pixel intensity or pixel brightness. Then we used this CSF value in a thresholding tool, which colored all pixels with the same or higher pixel intensity as this threshold value in a red shade. It's important to note that the lower the value used for thresholding, the more pixels will be picked up and the more red areas we obtain. However, the overall contrast within the dataset does not influence this, as the average pixel brightness of the CSF will also be lower in low contrast datasets. On figure 1, we see a nice example datasets of the thresholding in HOROS. The red zones here are areas where the pixel intensity was equal to or higher than the threshold value based on CSF, meaning the red areas indicate free fluid. Now, fluid with pixel intensity just below the threshold has not been picked up. That's not bad because we're only really interested in free-flowing fluid within the colon, not in fluid that's located in mucus. That's also how you compare to the intensity of the CSF as a standard for free fluid. After processing the datasets in HOROS, we open the individual slices in MSJ. Here we filter the image slice on red color and printed black and white image so we get a clear print of the fluid zones, which are now colored black. Next, we use the particle analysis tool to calculate the area of these black zones. After this, we manually exclude or include these regions of interest and determine where in the colon they are located, taking into account the three-dimensional anatomy of the intestinal tract. So we look at the next and previous slide within the dataset. For the patients that are fluid-fed, we sometimes can see a nice trail of fluid pockets, so we know these are located in the small intestine as the patient just drank half a liter. However, some other areas are more challenging, so we have expert radiologists on board that help us with mapping out the colon. So after obtaining the area of the black zones, we calculate the volume of the representative fluid pockets by multiplying the area to the slice thickness and distance between MRI slices, so we count for the inter-slice gap. This gives us the volume of each fluid pocket. The total fluid volumes on all slices gives us a total volume of fluid in the colon per dataset. 11 datasets have been analyzed so far, so these are very early results. The observed volumes in the colon range from 0 to 62 milliliters, so a high inter-individual variability is observed. This is in line with what's observed in similar studies in the adult population. There are also no trends observed in fluid volumes in relation to age, weight, fasted or fed state. We do see that being female may be linked to a higher volume in colon fluid, but we have to be cautious with making this assumption, as most of the analyzed datasets so far are from female patients, and we only analyzed 25% of the datasets so far. So as a conclusion, these are very preliminary findings, but they indicate that there's generally not a lot of fluid within the pediatric colon, although a high inter-individual variability is observed. These data will be useful to improve simulations that aim to mimic drug dissolution in the pediatric colon, improving drug development for the pediatric population. Thank you for listening.